Really, really quick. Converting to radians and converting to degrees. The only thing you have to remember is pi over 180 or 180 over pi. That is our key that converts them. Because 180 degrees equals pi, you're multiplying by 1. You're just doing a conversion, just like 12 inches in 1 foot. There's two ways to remember which order to have it. Remember, it's either pi over 180 degrees or 180 over pi. There's two ways to remember this. A is we have degrees here. In order for degrees to cancel out, the other side has to have degrees on the bottom so they can cancel out, just like when we had inches over inches. So that can show you which way to do this. So this would be 180, and this would be pi, and this would be 215 pi over 180. When you are in radians, you're supposed to leave it as a fraction. All you're supposed to do is simplify it down, and I simplified it down to something for sure. I don't feel like doing that all right now. Who got that simplified? Yeah. 43 pi over 36. That sounds about right. Do not just plug that in your calculator. All right, the next one. I'm going to show you another method to basically know which order to put it in. Whatever you want to come out, if you want radians out, make sure radians are on top of your conversion. If you want degrees out, make sure degrees are on top of your equation. So in this one, I want radians out. I want my answer to be in radians. So I'm going to put radians on top of my conversion, which is our pi. Once again, I want radians out, so I'll put pi on top. Working that all the way out, we should come up with negative 11 pi over 90. Does that sound right? Cool. On the next one, I want to convert to degrees. I want degrees out, so I'm going to put degrees on top of my conversion. So I'm just going to multiply this by 180 over pi. With degrees, I want a decimal. So you can plug that, either you can plug the whole thing in, or you can cancel out your pi's. However you want to do it, plug in your calculator, you're going to come out to 280 degrees. Finally, 7, even though there's not a pi in it, we know it's radians because there's no degree symbol. I want degrees out, so we're going to multiply that by 180 degrees over pi. If you do that multiplication, you're going to come up with 1260 over pi. That's where I came up with that 1260 there. But we want a decimal answer. You don't want pi if you're talking about degrees. So you're going to actually plug that in your calculator, and you're going to come up with that 401.1 degrees. All right, questions on any one of those four? All right, then really, really quickly, questions on the homework. Because we got a lot we got to cover today. Yeah, Nora.
I know it's an easy one, but could you please go over 109, please?
109? Uh, 109 says, find the linear velocity of a point on the surface of Earth that is 1 mile from the North Pole. All we need to get linear velocity is a radius, and we also need to know the speed it's revolving at. Because to get our angular velocity, you need to know how fast it's spinning, like 35 revolutions per second or something. How long does it take for a point on Earth to revolve all the way around? Yeah.
24.
So it takes 24 hours to do one revolution. So I'm going to go ahead and take a picture of my answer really quick. So this is my answer online. I said 1 revolution per 24 hours is any point on Earth. That's how long it takes the length of a day. I multiplied it by 2 pi, and now I had my angular velocity at pi over 12. Now I just need the radius to get linear velocity. Well, the radius is 1 mile, and here's my awesome drawing of you looking straight down on the Earth. This is the North Pole. And so the radius, because think about the Earth spins on an axis, right? So if you look down at it, this would be spinning in this direction.
Wait, but it's around the curve.
We're not worried about the curve. It's 1 mile. It's very, very negligible. It is 0.0000. I mean, 1 mile based upon our curve. So we're going to say the radius is 1 mile from the center. It's 1 mile from the center, so our radius is 1 for 1 mile. Yep. Other questions? Yeah. Yes, you can absolutely be a decimal point, because you probably just kept numbers in longer than I did. I rounded very early in that one. And if you noticed on all of them, I kind of rounded at different points to show you that we're going to be a point or two away. Yep. As long as you don't have 43.3 miles per hour because you rounded horribly and you're 20 miles per hour off. Yeah. Other questions? Going once, going twice. Make sure you check your answers. Make sure you check your answers. Maybe starting soon, I'm going to start checking specific problems. And even though you have homework done, you're not going to get the full points because you have that problem wrong. Remember, the only thing you can do is you can put question marks on stuff saying, I checked it, it's wrong, but I don't know why it's wrong. Don't just change it because I have it. Make sure you understand the changes you're making. If you don't, just put a question mark so at least I know that you tried it, you checked it, and it's wrong. Okay. Today's lesson is on SOHCAHTOA of sorts. SOHCAHTOA. SOHCAHTOA. You need to know it. You need to love it. Not so much for this. This we're developing the rest of the unit circle. And if you want to, you can just memorize the unit circle and basically forget most of the stuff we did today. This is why and how we're doing it. So SOHCAHTOA, first of all. SOHCAHTOA starts with so. That is our sine. And that is opposite over hypotenuse. Maybe I got ahead of myself. When we're dealing with sine, cosine, and tangent, what kind of shape are we dealing with? What specific triangle? A right triangle. We have to have a right triangle for us to use sine, cosine, tangent, and the stuff below. So we have a right triangle, and we're looking at a specific angle. We'll talk about what angle we're talking about in a second. Then we have ka. Ka is cosine. Cosine is going to be which is adjacent over hypotenuse. And finally, you have toa, which is our tangent. And tangent is oa, which is opposite over hypotenuse. I apologize if I go through this too quickly. Tell me to slow down if I'm ahead of you. Yes? Yes. I was just thinking I should say yes. Indubitably. It was a trick. No one fell for it. All right, so we have all of our sine, cosine, tangent information. Has to be a right triangle. We'll make a right triangle in just a second. There's 3 more. That is our cosecant, our secant, and our cotangent. They're known as our reciprocals. A reciprocal is either 1 over what we're talking about, or you just flip the fraction. So the cosecant goes with sine. Since sine is opposite over hypotenuse, the cosecant is going to be hypotenuse over opposite. Or you could just find 1 over sine theta, which is just saying flip it. Secant is with cosine. It is a reciprocal of cosine. So rather than cosine being adjacent over hypotenuse, this is going to be hypotenuse over adjacent, or you can write 1 over cosine theta, depending on what information you have. So if I knew the cosine value, I would use this one. If I knew just the hypotenuse and adjacent, I would use this one. Finally, cotangent obviously goes with tangent. Instead of opposite over adjacent, we're going to flip that and make it adjacent over opposite, which we could also write as 1 over tangent theta. All right, those are all 6 of them. Today, we're only going to focus on 2 of them, sine and cosine. That's all we're going to deal with today is just sine and cosine. Up until now, we worked on our unit circle. We worked on degrees and radians. And we now need to use those points to calculate specific sine and cosine values without being able to use our calculator. So I'm going to be able to say sine of 30 degrees, and you're going to be able to spit out. No one? 1/2. All right. Anywho, a unit circle is a circle with a radius of 1. That's important. The radius of 1 is the key to the whole unit circle. In fact, that's what unit means. It means 1. Also, this unit circle is centered on the origin. This is just the xy plane where this is the point 0, 0. It's important for you to keep your head up. It's also important for you to recognize that this is just the coordinate plane with points on it. So once again, this point right here is 0, 0. It's the point 0, 0. And we're going to give the points all the way around the circle. But it's just points along a circle on an xy plane. So we're going to use this to compare angles in degrees and radians. We're going to use this to find exact values of the 6 trig ratios at specific places. All right, for the point x, y in quadrant 1, the lengths x and y become the legs of a right triangle whose hypotenuse is 1. What that's saying is, I come over here and I pick a point on the circle. That point has an x value and a y value. Your x value is how far left or how far right you go. Your y value is how high or how low you go. So when I pick that point, you are moving right a certain number of units, and you're moving up a certain number of units. And completing that creates a right triangle. And since the radius of this circle is 1, the hypotenuse of any triangle we make is going to be 1 unit. That's going to be very, very important. I'm going to rewrite that triangle over here. We have that. We have this is 1. This is my y value. This is my x value. When we're talking about angles of a unit circle, yesterday we had a test on writing our degrees and radians. Those degree and radians are this angle here. They are from our x to this line here. So our alpha's right here, or our theta's right here. So this right here is the theta. That's the angle that we're going to be talking about. So in my drawing, I'm just going to put my theta here. Now let's talk about cosine and sine. We're going to talk about cosine of that theta angle, and we're going to talk about the sine of that angle. Cosine is just ca, adjacent over hypotenuse. So remember, that is adjacent over hypotenuse, where sine is opposite over hypotenuse. Well, we can put values to that. Not numbers, but we can at least put letters and some numbers. Our hypotenuse is 1. And if we look at our angle, the side adjacent to theta is x. So cosine theta, which is adjacent over hypotenuse, we can rewrite as x is the adjacent side, over 1, which is more simply our x value. Our sine theta is opposite. Our opposite's y, over our hypotenuse, which is 1, which is going to equal y. So if your brain went to mush on all this stuff and you're just copying exactly what I'm writing down and you don't know what I'm doing, pay attention to this one specific part. Cosine values equal your x values. Sine values equal your y values. It's good to know where it comes from. In case you forget it, you can actually develop it again. But you need to at least recognize that your x values are going to be your cosine values, and your y values are going to be your sine values. You have to know this. You have to know this. One trick is, if you need tricks, it's alphabetical order. Cosine comes before sine. So when we're talking about x values on the unit circle, we're talking about cosine values. And when I talk about y values along the unit circle, we're talking about y values. All right, this says the exact same thing. Sine is y, cosine's x. Okay, now let's talk about finding the exact values of sine and cosine without using a calculator. Because whenever we're doing this stuff, we're not going to use calculators. These are going to be our primary ones, the ones that don't take much work at all. And that is 90 degrees. When I ask you to graph a 90-degree angle on the unit circle, you would draw something like this. That's a terrible arrow. Or that's 90 degrees. If you look at what that points to, it points to that little point right there. This is just the xy planes. This point right here is 0, 1. It is the point 0, 1. If I just draw an x-coordinate, a y-coordinate, and put a point right there, that is point 0, 1. That's what we have right here. I'm going to make this a little bigger. Well, based upon what we did on the other side, that 0 is going to be our cosine value, and this 1 is going to be our sine value. And what that tells us, if you want to find the cosine of 90 degrees, and if you plug this in your calculator and come up with the exact same thing, you're going to come up with 0. If you plug cosine of 90 in your calculator, you're going to come up with 0. If you plug in sine of 90 in your calculator, you're going to come up with 1. So those points in the circle are your cosine and sine values. Pi over 2, that's equal to 90 degrees. That is equal to 90 degrees, it's just in radians. So in this case, you'd have to put your calculator in radians to come up with these answers. So pi over 2, that is still that same exact angle, and we'd still be going up to that same point, which is still 0, 1. What that means is cosine of pi over 2 also equals 0, and the sine of pi over 2 equals 1. Do not overthink this. It's just a point on a circle on the xy plane. If you know your x and y values, you know your cosine, you know your sine. Okay, our next one is 180 degrees. 180 degrees is half a circle. So that would be this angle here. But that would be pointing to that point right there. Now don't get lost on this. This is the point -1, 0. And why it's -1, 0 is because remember, the origin is 0, 0. So our x value needs to be negative to go in this direction. So it's -1. It doesn't go up or down, so this is the point -1, 0. In this case, our cosine is going to, or cosine of 180 degrees is going to equal -1. Our sine of 180 is going to equal 0. Just our x and y points. Did I lose anyone yet? Are we okay with those points? Those should be the easy points on tests, the ones that are right on the axes. Make sure you understand that, because it doesn't take any figuring out. You just have to know points: 0, 1, -1, 0, 0, -1. All right, this next one is -5 pi over 2. Now, up until now, I kind of allowed you to go in the negative direction if you wanted to. You could rewrite this stuff in the negative directions. Do you remember that unit circle we wrote yesterday? Do you want to write all of those in the negative direction? No, I wouldn't want to. I don't do it. What you're going to do if you are given negative angles, just keep adding 2 pi, find coterminal angle, so keep adding 2 pi or 360 until you have that least positive angle. That will go right on your unit circle. So in this case, we have -5 pi over 2. If you add 2 pi to it, and go ahead and try it, if you add 2 pi to it, does it make it positive? Does 2 pi work? Nope. We have to do it again. In fact, I can tell it's not going to work because 5 divided by 2 is 2.5. So I have negative 2.5 pi. Adding 2 pi to it won't work, so I have to add 4 pi to it. I'm just adding 2 pi 2 times, which is going to be plus 4 pi. We need a common denominator, so we'll have negative 5 pi over 2, plus that's going to be 8 pi over 2, which is going to be 3 pi over 2. Now, here's the subtle difference. This is going to end up in the same place, but just remember that this is a coterminal angle. This is coterminal. We are using it to find its position, but it is not the actual angle. So at no point should I say that, these are the exact same angles. They aren't. They just end in the same place. It's a subtle difference on tests because don't give me a coterminal angle as your answer. Give me that right angle as your answer. All right, so that looks like it's pointing straight down to that point 0, negative 1. So that means the cosine of negative 5 pi over 2 is the same thing as the cosine of 3 pi over 2, which is going to equal 0. And the sine of negative 5 pi over 2 is going to equal that negative 1. Because my x value is 0, my y value is negative 1. Make your stuff positive. Save yourself some headaches and just find that coterminal angle. Make your life easier. Questions? Yeah?
Why did you put the arrow in that direction?
Because I'm using the coterminal angle to find it.
Okay.
If you wanted to, you could write it, just know where it's going to end up.
Okay.
I'm just very specific at saying this is the coterminal angle. The correct angle would have went around twice, right, and then came that way. Yeah, the actual angle would have done that.
Okay.
But just to be clear, I'm never going to really grade you on your drawing. So you draw whatever you need to get your point across to yourself. Does everyone get that? I didn't actually draw the angle. I drew the coterminal angle. Are we okay with that? All right. We have more than 4 points on our unit circle. Just as a reminder, between each quadrant we wrote 3 more points. If you don't follow this, I'm not going to go into super detail. This comes from geometry. I'm going to use a little geometry to find these values. If you don't remember, it's okay, because you're mostly just going to memorize these values anyway. We're going to look at our first angle. That is this one here. Our first angle is pi over 6 radians, or 30 degrees. So I'm going to go ahead and write 30 degrees here. That's our 30-degree angle. That's our first kind of tick mark, which makes this a 30, 60, 90 triangle. A 30, 60, 90 triangle and a 45, 45, 90 triangle are very specific triangles that if you know one of the sides or the hypotenuse, you can actually get the other sides. Well, we know the hypotenuse. The hypotenuse is 1. And without going over all of this stuff, if your hypotenuse is 1, the side opposite your small angle is going to be your hypotenuse divided by 2. In other words, 1 divided by 2. This height is going to be 1/2. The one across from your 60-degree triangle is going to be your hypotenuse times square root of 3 over 2. So that's 1 times square root of 3 over 2, which is square root of 3 over 2. If you want to rehash 30, 60, 90s and 45, 45s, we could do that outside of class. I just don't have time to go over all the specific rules. What you need to know right now is that point right there is square root of 3 over 2, comma, 1/2. That is that point. Whether you know how to get that or just memorize it, either way works. What that tells us is that the sine of 30 degrees is going to equal 1/2, because that's my y value. And the cosine of 30 degrees is going to give me square root of 3 over 2. Finding that angle can also get me these values, because that triangle right there is also a 30, 60, 90 triangle, except now my x value is going to be negative. So that distance there is going to be a negative square root of 3 over 2. We're still going to go up 1/2, so we're still positive 1/2 there, which gives us the point negative square root of 3 over 2, comma, 1/2. Can someone tell me what angle this is? What is the degree measure of the actual angle that's created by that side? So I'm opening it up like this and going to that third tick mark. So. Here? Not 120, you were right with 150. And you can look at this and just go, well, if this is 180 minus 30, that's going to be 150. 120 is actually your first tick mark. Yeah. Because this is 90 plus 30 plus 15 plus 30. So that is actually 150 degrees. That's why it's important for you to know all of those measures. So that means that the sine of 150 degrees equals 1/2. And the cosine of 150 degrees equals negative square root of 3 over 2. Yes, Emma?
Why is the 1/2 positive?
Because you're moving up. So it's kind of like if I would, remember this is just an XY plane. Maybe I'll just do another slide. If I would go bloom, bloom, put some tick marks on it, right? That's 1, 2, 3, -1, -2. We'll call this 1, 2, -1, -2. And I pick this point right here. You would say that value is -2, +2, right?
Yeah.
Because we go negative in the x direction, positive in the y. Do you agree with it here?
Yeah.
Okay. This is an xy plane.
Yeah.
I'm moving in the negative direction for the x value, and I'm moving in the positive direction for the y value. If I put a point down here, they'd both be negative, because I'd have to go left and down. If I put a point over here, our x value would be positive, and our y value would be negative. Does that make more sense?
But it's like a 36 and a triangle.
We're just using that. I understand that triangle should have positive sides. We're just using that to get distances. So although this is a positive square root of 3 over 2 in the triangle, on our unit circle, the distance would actually be a negative square root of 3 over 2. We're just using that as a tool. Does that make more sense? A little better? Okay. Here's an important part here. This 30 degrees repeats down here and repeats down here, and these values are going to repeat at all those places. The only thing that's going to change is whether it's positive or negative. So it's going to be crucial that you remember this saying. All students take calculus. All students take calculus. And it's going to go around your unit circle just like this. All students take calculus. It's going to tell you which one's positive. Everything else is negative. Quadrant 1, all. All of them are positive.
Please excuse the interruption, but the boys' varsity soccer game has been canceled. So please stay in class, no early dismissal.
All right. All of them are positive. Students, sine is positive, so cosine's negative. Take, tangent's positive, so that means cosine and sine are both negative. Cosine's positive, that means sine and tangent are both negative. This will tell you which one's positive. Everything else is negative. If sine is positive, its reciprocal is also positive. That's why it says here, sine is positive, so is cosecant. but everything else is negative. It's going to be good for you to remember this saying. All students take calculus, or just remember all sine, tan, cos. Check out that baby. It's not disgusting. It's not disgusting, but you do need to know this by tomorrow. If I quiz you on this tomorrow, you need to know all of these values. Now, before you think that's impossible,
It's a joke, right?
it is not a joke.
Wait, you're not joking?
Hang on.
Oh, what's it saying?
Hey, there's a trick. Let him talk.
Don't.
It's not hard to remember this. Look at every denominator in every fraction.
Well, that really helps.
Hang on. They're all fractions that have a denominator of 2. So on the quiz, I'd probably put a bunch of fractions in these places, and you just got to put 2 under each one of them. There's only 3 values. You don't have to memorize these because these are just numbers on xy plane. This is just 0.01. You shouldn't have a hard time memorizing how to read an xy plane. It's just 0 in the x value, 1 up, -1, 0, 0, -1, 1, 0. All the rest of these are just 3 possible numbers. They are 1/2, square root of 2 over 2, and square root of 3 over 2. Another hint. Look at the middle dot in all of them. They're both square root of 2 over 2. In that middle dot, they're both square root of 2 over 2. Don't worry about the negatives and positives yet. This is how I do my unit circle quickly. There's a nice pattern, right? You don't have to, it's not just memorizing a whole bunch of numbers. I focus on my sign values. Do you see this 0? What I do is I go 0, 1, 2, 3. Then I come over here and go 3, 2, 1, 0. 1, 2, 3. 3, 2, 1, 0. Cosines either the same, where square root of 2, or it's just, if it's 1, the other one's square root of 3. If one's square root of 3, the other one's 1. So if you have all your sign values down, cosine should be really, really easy. Now, the only thing you have to work on is negatives and positives. But if you remember, all students take calculus. You don't even need to memorize which ones are negatives and positives. All you have to go is all means everything's positive. Students, sine is positive, cosine's negative. That's why all our sine values are positives. Our cosines are negatives. Quadrant 3, all students take. Tangent is positive. We haven't even talked about tangent, so everything must be negative. Calculus, cosine's positive, sine is negative. This is actually super easy to remember in that quick of a thing. Remember, they're all fractions. They're all over 2. And sine goes 0, 1, 2, 3, 3, 2, 1, 0. And cosines are just the opposites. All right, so this is completely doable. If I quiz you tomorrow, I do expect you to know it all, especially because most of you should already know your your radians and degrees. So you are going to be in charge of knowing your degrees, radians, and that. I did put blank ones on the Google Classroom if you want to practice filling it out. The better you work on that, the better, I guess. All right, real quick, there was 4 more problems we're going to do. We're not going to do all 4 of them. We're just going to do 2 of them together. We're just going to go ahead and do 2 of them together. So what one should I do? I'm just going to do those first 2. Do you see those 4 problems sitting by themselves? One says find the sine of 135 degrees. Let's go ahead and do that one together. I'm going to do it off to the side. So we're supposed to find the sine of 135 degrees. This is super easy if you know your unit circle. If you can fill out your unit circle on your own, these are super easy problems. All you need to do is find 135 degrees. Boom. Come out here. It's either this point or it's this number. And if you're good, you're going to know that cosine is your x value, sine is your y value. So I'm talking about 135 degrees. Our sine is our y value, so this is just going to be square root of 2 over 2. If I asked for the cosine of 135, you would just give me negative square root of 2 over 2. The next one says find the sine of 5 pi over 4. We just got to find 5 pi over 4. Yeah, Nora.
It's negative square root of 2 over 2.
It's going to be, what was I looking for? Oh, yeah, negative square root of 2 over 2. Because 5 pi over 4 is right here, and my sine is on that side. What do you think I should do if I had a negative, if this was negative 5 pi over 4? What should I do to that angle first? So in the next problem, if you look at the next one, it says find sine of negative 7 pi over 6. What should I do to negative 7 pi over 6 before I even start, Mary? Not the reciprocal. That's only if we're dealing with cosecant. So I want to do something with that negative. Add 2 pi to it to make it positive. So in that next example, you have sine of negative 7 pi over 6. I would add 2 pi to it, which would make it 5 pi over 6. And you should find your answer is 1/2 for the next one. So sine of negative 7 pi over 6 should be 1/2. See if you can do that. If you can't get it, ask me questions. Otherwise, yeah.
I don't know if this always works, but it worked on this one. If you just take the regular 7 pi over 6, and then you find negative 1/2, and you just flip it because it's opposites. I explained that really.
No, I get what you're saying. And it has to do with the fact that we're either down here for negative, or this is actually positive 7 pi over 6. Negative 7 pi over 6 would have been right here.
Mm-hmm.
It's the reciprocal nature of this unit circle. It has to do with coterminal angles working. So you are 100% right that it'll work every single time.
Okay.
But make sure you know what quadrant you're in to know if it's positive or negative. I'd refrain from doing that because you confuse yourself really quick. I would just make it positive.
Yeah.
Just make it a positive angle. All right, other questions? You sure? Oh. Your homework